Okay, picture this. A criminal thinks they're being clever. They've got a stolen firearm, or maybe an engine block, and they take a grinder to the serial number. Sparks are flying, the metal gets perfectly smooth, and in their mind, that's it. The evidence is gone, the object is now a ghost.
But here's the thing, they couldn't be more wrong. What they don't realize is that to a forensic scientist, that number isn't really erased at all. It's just hiding. It's become, well, a ghost in the metal. So, how do you do it? How do you read a message that isn't there anymore? Well, it's an incredible story where physics and chemistry team up to solve crimes. See, the secret isn't about what you can see on the surface. It's all about discovering the memory that's locked deep inside the material itself. To a scientist, what the criminal did is kind of like ripping the top page out of a notebook after someone wrote on it really, really hard. You know, the words on that top page are gone for sure, but the impression is still visible on the page underneath. All the criminal did was remove the most obvious surface-level part of the problem. So why? Why does that impression, that ghost, stick around? Well, the whole secret lies in how most of these serial numbers are put there in the first place. We're not talking about ink here. We're talking about pure brute force. It all comes down to a key scientific idea called plastic deformation. Now that sounds super complicated, but it's really not. All it means is that when you hit metal with enough force, you don't just dent it, you permanently change its microscopic structure. You're literally locking that shape into the metal's memory. So here's how that memory gets created. A big steel die slams into the metal, right? That force radiates down deep into the material, and it crushes the tiny metal crystals together. The best way to think about it is like pushing your hand into a memory foam mattress. Even after you pull your hand away, the shape is still there for a bit. With metal, that impression is permanent and it runs deep. This compressed area is what we call the shadow zone, and that is the ghost we're hunting. Okay, so we know the ghost is there. It's hiding out in the metal's memory, deep below the surface. But it's totally invisible. So how in the world do we summon it? How do we make it show up? Well, this is where the chemists get to have all the fun. And believe it or not, this is it. This is the whole magic trick, the entire process. And it boils down to one beautiful, elegant rule of chemistry. See, the parts of the metal that got crushed by the stamp, they're more stressed out, they've got more energy, and they're less stable than the metal right next to them. And because of that, they react with acid just a tiny bit faster. So here's how they put that principle into practice. First, a technician sands the area until it's polished like a mirror. Step 2, they swab on a special acidic cocktail, usually something called Fry's reagent. Then the reaction starts. The acid immediately begins to eat away at that stressed shadow zone, just a little quicker than the unstressed metal around it. And finally, the ghost of the numbers slowly emerges, appearing as a darker outline on the surface. It's amazing. But here's the dramatic twist in the story. Bringing this ghost back from the dead isn't a permanent fix. In fact, the very same chemical that reveals the secret is also actively destroying it. It is an absolute race against the clock. And this is so crucial. You really only get one shot at this. If that acid is left on for just a few seconds too long, it won't just highlight the stressed areas, it'll dissolve the entire surface, and the ghost is gone. For good. The number appears for just a fleeting moment, and that is the team's one and only chance to see it. This is exactly why the whole forensic process has to be so precise, like a perfectly choreographed dance. There has to be a photographer standing right there, camera ready to go. The very second those digits are clear enough to read, click, they get the shot. And then immediately they have to flood the area with a neutralizing agent to stop the chemical reaction dead in its tracks. In the end, that photograph becomes the only proof that the number ever existed at all. Now, this whole acid etching technique is absolutely brilliant for those old school stamped numbers. But of course, technology never ever stands still, and both manufacturers and criminals are creating a whole new set of problems for forensic scientists to solve. This comparison really shows you the challenge they're up against now. Stamping, on the one hand, uses force. It creates that deep, compressed shadow zone we've been talking about. But laser etching, that uses heat. It just burns the number right onto the very top surface. There's no deep compression, no plastic deformation, and so there's no ghost hiding underneath. When a criminal grinds off a laser-etched number, there's usually nothing left for the acid to find. And this has kicked off a brand new cat-and-mouse game. Scientists are now scrambling to develop new methods, like using super-sensitive thermal imaging to look for faint heat signatures left by the laser. Meanwhile, criminals are learning they just have to grind a little bit deeper. It's this constant, ongoing battle between scientific innovation and criminal ingenuity. When you get right down to it, this whole process is just a beautiful, real-world example of Locard's exchange principle, which is really the cornerstone of all forensic science. It's a simple idea. Every contact leaves a trace. You simply can't touch something without leaving a piece of yourself behind and taking a piece of it with you. A criminal might think they're wiping the slate clean, but they can't erase the laws of physics. And that kind of leaves us with this one big final thought. As manufacturing gets more complex and as criminals get smarter, the tools we use to find the truth have to get smarter too. It really makes you wonder, who's going to win this invisible arms race? The people trying to hide the truth or the scientists trying to reveal it?